Well, hello everybody. Today we're going to talk about SfM10 structure from motion 10. So here I am in the software. Inside the software tab on my blog. This is where you have the link to download SfM10. So in this video I'm going to talk about SfM10 only, and the next video I will talk about the other one, the MVS10. So right now I'm just focusing on the structure from motion part. So this is the thing that you have to download. So now, assuming that you have downloaded it, in my case I'm putting it here. So this is the archive, Ubisoft 3D 10x64.rar. So you extract that, and I'm gonna put it, and it gets deployed here in this directory. So that's the directory that you get, and in there you have the SfM10, the executable, the manual, and you have a test case to check that everything is working right. So you can go in there in the test. There's a bunch of files, but there should be a file called SfM10.bat. So you edit this one. There it is. And here, this guy, you copy you get rid of this, and you copy the actual path to the executable. So how to do that? So this is test. So now you go back one. This is the executable SfM10, which means that the path is going to be here. So you do this, and you do right click, copy, or whatever, Control C. So copy, and you paste that into here, into that thing that we just looked at. So you put it here. That's it. Okay, so but here we're gonna do a different one. So let me see. I created a directory here, SfM10 examples. So this is this one. So I've taken four pictures. It's very fascinating. It's a picture of a AC compressor gizmo. So it's 4 pictures taken. I think I must have extracted from a video. So this is the first one, second one, third one, fourth one. So it's a slightly different angle. What else? Okay, so this is the batch file with the correct path to the executable, and the input file. So before we go into the input file, we should really take a look at the manual, which the manual is in yeah, it's wherever you extracted the archive. So the manual is here, SfM10 manual, and it's actually here. I got to say that manual is pretty good, so you should really read it. I think I really made an effort when I wrote that one. So SfM10 creates a sparse 3D reconstruction of the scene. To be more precise, it's a prerequisite for MVS10, which creates a dense 3D reconstruction from that sparse 3D reconstruction. So it's like a preamble to MVS10. It basically computes the orientation and position of the cameras corresponding to the pictures in the input. So yes, so the input is a set of images taken by a camera with known focal length, where we'll get back to the focal length later. Yes, so SfM10 requires all images to have the same dimensions and orientation. So they all have to be either landscape or portrait. And the output is a file that I called the.nvm, which contains the camera parameters and the sparse representation. And you can use Visual SFM to look at it. We'll look into that at the end. And it also outputs a PLY file, which is a file that contains the point cloud, which you can open by MeshLab. But I prefer to use Cloud Compare for that stuff. And also for fun, I give a sequence of frames, I think 12 frames, named the underscore. I don't know if it starts at 00, 00, 01, 02 or 01, 02, 03 up to 12. And that you can load into GIMP and create an animated GIF. Here I explain what SfM10 does. It's pretty basic. Each image you find the main feature using SIFT. For each image pair you find the matches, and of course you only want the good matches, so you use some kind of algorithm like ransack. You initialize the 3D reconstruction with the initial camera pair. Here you perform bundle adjustment on the camera poses, that is the orientation and the location and the 3D points as well. And then for each additional image you do what's called a resectioning. So basically you copy the camera pose and you add 3D points to the reconstruction, and again you perform BA on the camera poses and the 3D points. Okay, so now I think we can go into this is the input file, what it looks like. First line, number of images, that's easy. Image file name, that's easy. Focal length in pixels, that's a little bit, I'll explain that. Initial camera pair. Number of trials. Usually it's, I think I use 10,000 all the times. Every time I use 10,000, I don't think I changed it. I think it's 10,000. Or is it 1,000? Let me see. Number of trails. I think it's 10,000. Let me see. Let's look into the actual examples. SfM10. What do I use here? Focal length. 10,000. So I use 10,000. That's the 10,000. That's the number of tries in there. What is it? Oh man. Number of trials. So that's the ransack stuff. So that's 10,000. Leave it as is. Max number of iteration for LPFGS bundle adjustment. I think it's 1,000. 1,000. This one. Leave it as is. Then the minimum separation angle and the max reprojection error. Yeah, this is to get rid of low confidence 3D points, so the 3D points that we are not too sure about, and this is a way to get rid of them. you can get rid of them using that mean separation angle and the max reprojection error. And actually in this manual I have a nice picture that explains that. Two nice pictures. That's a good one. Separation angle. Yeah, so you want a priori the separation angle to be greater than 0 in order to get rid of points that are too far away in the scene. Because the thinking behind that is that as the separation angle goes down, the accuracy of the location of the 3D point goes down as well. So if the separation angle is too small, the likelihood of the 3D point to be wrong is very high. So in this picture here you have, for instance, a camera pair, so two camera centers, focal length, the two image planes, the 3D point is here, and the angle between the two rays, each ray going from the 3D point to the camera center. So the angle between the two rays is the separation angle. So you basically want to cap on the low side that separation angle in general. And then I have another picture for the other one, the reprojection error. So, okay, when you do the SIFT stuff and you match the SIFT features on two different images, each feature is going to have image coordinates in the image plane. That is the coordinate of the pixel on the image. So it's an X, Y, or IJ. So that's the pixel. Now, from that image coordinates, somehow you got a 3D point using two cameras. So that's your 3D point here. Now you reproject it on the image plane because you know the camera center. So that's the ray is defined by the camera center and the 3D point. So this is the reprojection here. So if that distance here between the 2 points in the image plane, that distance here between the 2 points in the image plane is called the reprojection error. So clearly you don't want that reprojection error to be too high. So the reprojection error can be controlled by that parameter. So this is the control of the separation, and this is the control of the reprojection. So this is the max reprojection error allowed, and that's in the dimension is pixels. Okay, the last two parameters, the pixel radius and the angle amplitude, has to do with the GIF stuff. So pixel radius it just controls the size of the pixel in the frames that the program is going to create. And the amplitude, the angle amplitude, is basically the wobble. The higher the amplitude, the more wobble you're going to get into your animation. So yeah, so if you want, if you're interested in that SfM10, you should really read that manual thing. It's actually it's pretty good. It's pretty well written, if I say so myself. And here I also explain the focal length. So the focal length, yeah, the focal length, you need to have it in pixels. So the focal length in pixels is equal to the image width in pixels multiplied by the focal length in millimeter divided by the sensor width in millimeter. So usually you can find that stuff either in EXIF data of a picture taken by the camera, or you can get it from some website that's going to list all the CCD widths of all cameras. So you can get that information either from the EXIF or from the Google. In my case, iPhone 4S, that was a long time ago. That's an old phone. Yeah, the focal length is 428 in millimeter, and the CD width is 454. So that gives you a focal length for the 1810 if the image, the width is 1920. Yeah. Usually what I do, I don't even care about this. I just take my focal length to be equal to pretty much the width of the image, maybe a little bit less, maybe a little bit more. I don't think it matters that much. Usually you can tell if you're wrong by looking at the 3D scene. If it's too stretched or too compact, then you can change the focal length so that the 3D scene looks correct, and that's pretty much all you have to do. But a good guess is around the image width for the focal length. So yeah, you don't want your images to be too big, otherwise it's going to take forever, because SfM10 is not running in parallel, so it's a single processor. So if it's too big, it's going to take forever. So let's look quickly at the size here. Yeah, so it's 1920 by 1880. So that's 1920 by 1080. So yeah, you don't want to go higher than that, I think. So okay, so this is the batch file. So let's just run that thing. Yeah, I probably should have explained the initial camera pair now I think about it. Yeah, so this is your images. So this is the index of the image, 0, index 1, index 2, index 3. So the initial camera pair refers to this. So in this case here, my initial camera pair is 0, 2. What I usually do is that you basically want to use your initial camera pair so that the viewpoints are slightly different. So the camera center are enough apart from each other. So if I think I must have taken 0, 1 and probably didn't work very well. So then you go to the next one, 0, 2. Basically, I'm assuming that I pretty much did like a cha-cha thing. So I just moved. So 1 and 0 are pretty close to each other. 2 and 0 are a little bit further apart. 3 and 0 are more further apart, and 4 and 0, 4. No. So yeah, so 1 and 0 is probably too close. They're too close to each other. So I used 0 and 2 as my initial camera pair. I mean, if you have problem with that stuff, just send me an email and I'll tell you. So here I'm running this stuff. What's it doing now is first it's computing the SIFT features, and then is looking at each pair of images, and is computing the matches. And he gets rid of the bad matches using a ransack. So that takes a while. Yeah, so now it's almost done. And what you want to look at is, okay, so that's how many 3D points you have in your sparse reconstruction. So 4467. The average reprojection error, 0.24. So that's pretty good. Max 376. That's good. The average reprojection error, you want it to be below 0.5 if possible. Max reprojection error, well, I mean, I mean, it's just a one. I mean, it might be an outlier here and there. Should be okay. And what else? Yeah, here, the depth. So that's the depth of your scene. It goes from 8.9 to 20.9. That's very nice. It's if you have a max depth that's very large, it means that there's probably something that you should have done differently in the input file. Let me go back to the input file. See what I did. Oh, I cannot access. So let me leave this here and go back to the input file. Input file is here because here this is my input file. So I use 2200 for the focal length. Initial camera pair 02. Okay. 10,000 for the ransack stuff, the iteration. 1000 for LBFGS. And I use 0.0 for the minimum separation angle, meaning that I actually don't care about it. And I use 10,000 for the max reprojection error, which means I don't care about it. And this is just for the animation stuff. So in this case, the scene seems to be okay because you can see that the mean and the max Z of the scene looks okay. But if you get very large number for the max, you may want to change those. In particular, that one actually, the separation angle. Just put 0.1 for instance. That will get rid of points that are near infinity in that 3D scene. Put 0.1 if you have a problem. If the depth, if this is large, max depth here, if this is a large number, change your change this one, the minimum separation angle, from 0.0, which means I don't care, to let's say 0.1, and that should get rid of that problem. You should get a max depth that's much lower. Now, as you probably noticed, SfM10 outputs a lot of files. This is because if you need to rerun, to restart, SfM10 can use the information in the files and it doesn't have to recompute everything. And yes, all those files with suffix SFM, if you restart it and you want to run from scratch, you need to delete all of those, the SFM files. It's explained in the manual. Yeah. Okay, so if any of the following parameters is changed, focal length, initial camera pair, max number, mean separation, blah blah blah, there is no need to delete the SFM files, which means that SfM10 is going to read those, use them, and it's going to go faster. But any other parameter that you change, you need to get rid of all the SFM files. You need to delete those. So make note of that if you change parameters and you want to restart SfM10. So now we're going to see how we can visualize that the.nvm, which contains all the information regarding the scene, the 3D scene that we have just constructed. So to visualize the scene, we're going to use Visual SFM, which is a software that you can use. It's free to use. Just Google Visual SFM, you'll find it. So to load that .nvm, that SfM10 has generated, you go into you click SfM, load and view match. Okay, so this is where we run SfM10, so there should be a file named .nvm, and this is the one that you load. So as you can see, all those points, that's the those points are the points that SfM10 has created. This is the sparse 3D reconstruction. What's going to happen is that this NVM file, we're going to use it in MVS10, and MVS10 is going to create a dense representation. So this is a sparse representation. And what you see here, those four things, that's the cameras. That's the four cameras corresponding to the four images. It shows the location of the camera that took the picture. Whatever SfM10 thinks the camera was for each picture. So I'm not sure the order. Yeah, so this is 0, 0, so that's the first image. That's the second one. That's the third one, that's the fourth one. So, and if you recall, my initial camera pair that I use is this one, 0 and 2. This is 0 and this is 2. I think the 0 and the 1 were too close together, so that's why I use 0, 2, which they are further apart. So that's graphically, that's how you explain it. Okay, let me rephrase that. So this is, so as you can see, I shot the scene by doing a kind of cha-cha, going left to right. So so this is 0. And if you use initial camera pair 0, 1, which is 1 is this one, the cameras are too close to each other, so you're not going to get a good accuracy. So that's why initial camera pair I use 0 and 2. They are sufficiently apart, but not too far apart. If the cameras are too far apart, you won't have enough SIFT matches. So there's a balance between I mean, you want them enough apart, but not too far apart. So that's why you start with 0, 1. If it doesn't work, you go to 0, 2. If that doesn't work, you go to 0, 3, assuming that your picture were taken going from left to right, let's say. I'm sure you'll figure it out. So yeah, so Visual SfM, that's pretty cool to see. Okay, so the left click translates, right click rotates, and the wheel zoom in, zoom out. So it's pretty easy to use. Now if you go back to the directory, if you want to create an animation GIF, you can load them into GIMP. Okay, so they are here, 2_00 to 2_11. You load those into GIMP, you rescale them if you want, and then you export as a animated GIF, and that gives you the wobble. If the wobble is too wobbly, you can just reduce the angle. And so in that case, you just change your that parameter in input file, and you can rerun SfM10 without deleting any of the .sfm files. Okay, so I'm done with this, but in the next video I'm gonna talk about MVS10 and how to get a dense representation using the results of SfM10. So until then, see you around. Yeah, maybe it would be a good idea if I show you how to load the those frames into GIMP. So that's what you do, is that you do File, Open as Layers, and you select all of them. So Shift up to 11, and you open that. That's what I did here. Here they are in reverse order, but it doesn't matter. So now what you do is that you export as. So I'm going to keep the name .gif, and then it should ask you if you want to you have to save as animation, and here you can choose the delay. Hopefully it's okay. So we just export that. I made a mistake, I should have resized them. I should have resized them. No, that's okay. No, let's save it, and we are going to resize it later. So let's get rid of this, and let's load the GIF file that we just made. We're going to resize that one. Let's resize that one. That should work. Scale image. So let's do 600. And I think it rescales everything. Yeah. So now you can export. Let's re-export. Let's override it. Yeah, replace as animation. Perfect. Export. Beautiful. Now we can. It's this guy, and you have to open with a browser. So let's look. Explore. Yeah, sure. No way. So that's the scene. As you can see, the wobble is pretty pronounced, so you can reduce it by changing the angle in input file. So again, this is a sparse reconstruction, but we're gonna get the dense reconstruction with MVS10, and that's going to be the subject of the next video. So stay tuned. So again, see you around for the next video. Bye.